All right, here we are again, folks, at our expert U-boat plotting station here, otherwise known as the table on which my wife wraps Christmas presents. So I've got my piece of graph paper here, okay? I've got my handy-dandy pencil, and then I've got a couple pieces of kit here. I've got a ruler, super high-tech stuff here, by the way. Ruler, protractor, okay, and we're set, all right? So the other thing I've got noted is I do have Arcturus. I have the offset, or the intercept rather, and the azimuth noted for the first site, and then for the second site, Regulus, I've got the intercept for that one +7 and 18.6, or excuse me, 186 degrees. Okay, so you'll see how these work, but anyway, I've got these noted here, so we're ready to go. I've also got the assumed position here, which is 54 degrees 31 minutes north, 3 degrees 32.8 minutes east. All right, and it was at 0630. Okay, so these are the sites we already taken. We don't really need this information anymore, but because we have all this is what we need. All right. So before we get into the nitty-gritty here, I am going to show you what the historical site reduction tables look like that the Germans put out during the war. So this is called the F-Tafel, okay? And I can go through, these are the tables that they used. I can go through these maybe at another time if people are really interested in using this. But what I did do is I went through and I refigured the formulas so that you could actually use these here, so that you can actually use a scientific calculator actually using with 3 memory slots. As long as you have a scientific calculator with 3 memory slots, you're actually able to do this in minutes, in seconds, and get all the information you need. Okay, so but anyway, this is sort of an interesting document. This was the 1941 edition of this, but this is basically what was given to navigators. This is introduction and instructions for use of the F tables. So, but anyway, the plot we're going to look at is actually this is the actual site reduction data. But this is what it looks like here. Ours is going to be more simple than this, but anyway, they plotted on graph paper like this, what they called millimeter paper, and this is essentially what a site reduced plot looks like of an intercept. Okay, there's different examples in here, but basically, this is essentially what ours is. Somewhat what ours is going to look like. You've got the actual azimuth that's pointing to, this case, to the North Star. The azimuth pointing to the North Star, and then you've got an offset plot here. That's the line of position. And then the second site was to Altair, which is another star. And there you go. There's the line of position. There's the fix right there. Okay. So this is maybe of interest to people, but these are the tables themselves. All of this can be done with a scientific calculator nowadays. Okay, so anyway, that's the F-Tafel, and of course I had to print it off and put it in a binder. Who would I be if I didn't do that, right? So anyway, back to our graph paper. So I've got this set up. Our assumed position is actually here. Okay, so I've got our latitude line drawn, 34 degrees 31 minutes north. And then our assumed longitude, 3 degrees 32.8 minutes east. All right, we're going to do all of our plotting from this point right here. All right, so bear with me. Now, the first piece of information that we need is, we'll plot Arcturus first. We know that the azimuth is 105 degrees, okay, and it's minus 6.6. So what we'll first do is we'll plot our azimuth of 105 degrees. All right, so the way the Germans plotted is they didn't plot in true. They plotted based on what quadrant it was, and the angle in the quadrant. So 105 is obviously the bottom right quadrant here. It is so we simply just take our protractor, and I'm just going to try to do this somewhat easily while looking at the camera at the same time, but there you go there. Okay, we're lined up. 90, 10, 105 right there. All right, we make our mark. And again, you know, you don't have to do this on graph paper. You can do this in Wolfpack on the map. All this stuff is still valid, okay? So we're going to draw our azimuth like so, okay? Whoops, broke my lead here. Draw our azimuth, and we're going to point it in the direction of the star, okay? The star is Arcturus, okay? Now, we know one piece of information we have is that it's 6.6 minutes or nautical miles away. That means we actually have to extend the rear side of the line because it's not toward the body. Toward the body meaning this way, okay? It's not toward the body, it's actually away from the body. So if it were a plus intercept, we'd go this way, 6.6 miles. And if it's away, we go this way, 6.6 miles. So what is 6.6 miles? Well, the easiest way to do this is just make it so that one square in here, one of these incremental distances here just equals 1 nautical mile, okay? Your graph paper may be different, but mine is delineated in inches. So you can see a half an, whoops, you can't see. A half an inch is actually 1 nautical mile here. All right, so 6.6. We're gonna go. We're gonna go 1, 2, 3, 4, 5, 6. Okay, and that's gonna be about right there. 6.6 is here. Let's check that again. Again, a half an inch is, or excuse me, a quarter of an inch. Did I say a half? I said a quarter of an inch is 1 mile. 1, 2, 3, 4, 5, 6.6 or so. Okay. So now we make our mark here. This is our intercept right here. The next step we do is plot the line of position. Very easy. All we do is we simply draw a line 90 degrees to that to the azimuth line. All right, like so. And that is our first line of position. The Germans delineated it with a Roman numeral 1. Okay? That's our first line of position. That is the Arcturus line of position. Okay? So the next one is Regulus. What do we got? We've got 7 toward, so 7 nautical miles toward at 186 degree azimuth. Okay, well that's, the Germans would have called that south 6 west because they measured in quadrants and angles from quadrants. So they would have said it was south and then 6 degrees into the southwest quadrant, 186. All right, so let's measure that out. That's going to be pretty simple. We just simply go like this, and we go 6 degrees, so that's going to be right there. All right, and then we draw our azimuth, which is going to be okay, it's going to be like this. Now we know it's towards, we don't have to extend the back end of it too much, right? But there is our, and that goes to Regulus, okay? All right, I'm just going to zoom out a little bit so you can see everything. All right, so that's our second azimuth there. Now we know we need to go 7 toward and draw our 90 degree line of position from there. Okay, so again we use our inches trick, and we say 1, 2, 3, 4, 5, 6, 7. All right, that's about here. All right, and then we measure our, we do our line of position from there. A weird angle here, so bear with me. Okay, that's going to be right about there. That's line of position 2. Now we need to extend these because they're not intersecting, right? So the line, here's line of position 1. We need to extend that over here, and then line up. This is 2, excuse me. That's second line of position. The first line of position we need to extend down. A bit of a shadow there, but anyway. All right, so there we go. Where these lines of position, so just to recap, all right, we drew the azimuth in the direction of the body based on what the sight gave us, okay? We knew the offset was away 6.6 nautical miles, so we measured that away, and at that point we drew 90-degree line of position from there, okay? The second one, 186-degree azimuth, we draw it toward Regulus that way with the arrow pointing there. We know it's +7, our intercept was +7, so we measured 7 nautical miles down, and at that point we drew our 90-degree line of position, and at where those two intersect, that's our fix. All right, now what do we need to do now? Okay, so we know that the lines of latitude do not converge. They are always equidistant. They're always 60 nautical miles apart. Okay, so this will be our actual latitude. So what do? So we know it's 54. Our assumed position was 54 degrees 31 minutes north. We simply count down 31, 30, 29, 28, 27, 26, 25. So let's just call it like 25.2 maybe. So 54 degrees 25.2 minutes north. Let me just check that again. Should be 31, 30, 29, 28, 27, 26, 25.2. That's about right. Okay, so that's our actual latitude. That's good. Okay, longitude is a little different. Longitude, because this is a flat Earth type of scenario, and our actual map is not a flat Earth, we need to actually convert, do a little graphical trick here to get it that way. So the first thing we do is we draw a dotted line. It needs to be 90 degrees, but we can kind of eyeball it here. Just do a dotted line like this, okay, toward the assumed longitude like this. Okay, now what we do is we take our latitude, which is 54, all right, and we actually draw an angle up from this line we just drew, you know, from our calculated position, 54 degrees up. So 10, 20, 30, 40, 10, 20, 30, 40, 54-ish, 54, 55 degrees up, okay? Now what we do is we draw a dotted line there. You're probably wondering, what the heck am I doing? You'll see in a second. All right, so boom, 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 boom. Okay, what we've done here, okay, is we're trying to calculate a secant, because what we need to figure out is the lateral distance here on a flat Earth is not the same as in longitude, degrees of longitude, or minutes of longitude, I should say. It's not the same as it would be if we transfer this to the actual map, right? So what we need to do is, instead of saying this is 1, 2, 3, 4, 5, 6, 7, 8.3 nautical miles, or rather minutes west of this longitude, it's actually this distance west is what we're actually going to plot. So we need to measure that. And that's ultimately what we're going to subtract from this longitude here in order to get what we need to plot on the map. So we're going to measure this now. It's going to be, we can just do quick math because we know it's going to be one of these is 1, 2, 3, 4. So we can say 1, 2, 3. Oops. 1, 2. Excuse me. 1, 2, 3, 4. Yeah. 1, 2, 3 times 4 is 12. 13. 14.9 let's just round it to 14. Okay, so 14 minutes is actually, we need to go 14 minutes back from 32.8. All right, so let's just do minus 14. So it's going to be, our actual longitude is going to be 3 degrees. We got 0.18, okay, 18.8 east. Check my math there. Yeah, we're good. Okay, so 3 degrees, 18.8 minutes east. So 3 degrees. Okay, this is our fix right here. This is the trick we have to do in order to get it, get the lateral distance in degrees and minutes correct to put on the map. Okay. So that being said, that's all we have to do here. That is a 2-star fix. It doesn't get any more complicated than that. So let's go back to the map and plot this and see how close we were.